Proportions. How many of you have heard the word proportion before, or proportional, or out of proportion? Can you guys give me maybe a couple ideas of what you mean when someone says proportion or proportional? So what's your thought, Tyler?
How much someone eats.
Yeah, portions, like how much of a portion. Yep, portion's definitely in there. Part, portion is part.
Proportion.
Okay, yes?
Like in art, if you're drawing something, you use to scale with something else.
Yes, in art, if especially we're doing like something that is more realistic, then you want to be proportional. So when I draw a person, I want to make sure that the head is proportional to the body, or the hands are proportional to the arm. You want to make sure they match up somehow. Okay, proportion. Anything else? You've blown something out of proportion. You've taken something that should be maybe this big and you've made it that big. It's not supposed to be that big. It's only that big, out of proportion. Yes?
What do proportions have to do with our unit, our lesson?
Okay, we're going to get to that in just a minute. I just want to hear your thoughts because I want to know what you guys know already. But here's one that's an example. Anyone bake or cook at all?
My sister does.
Okay, I've done it a few times, baking, cooking a few more times, but I know this, for example, like if you have a recipe for cookies, a dozen cookies, if you have a recipe for a dozen cookies, they may call for half a cup of sugar, right? But if I don't want just a dozen cookies, maybe I want 4 dozen cookies, do I still just add half a cup of sugar? No, I have to add, does anyone know? 2 full cups of sugar because I want to keep it proportional. So if I do this, guys, I have a recipe for a dozen cookies, half a cup of sugar, and I'm like, I need 4 dozen cookies. So I get 4 dozen cookies ready with all the other stuff, but I only pour in a whole cup of sugar, and that's it. Is that proportional? No. And you're like, well, that doesn't matter. Someone in the other class said, it might be healthier. Yeah, it'll taste healthier. It'll taste more like cardboard, which is like fiber, which is good for the system. So guys, it is not proportional. It has an effect on the product. In this case, cookies. And I don't know any of you who have baked or cooked before. Have you ever not been proportional with cooking?
Yes.
You know, things happen when that occurs. Okay, so what are we talking about with proportions? A proportion in math, and we're going to tie it into those other concepts in just a bit. A proportion is, and here's a key word that we've seen before over and over again, is an equation. It's an equation. That's a key word for this definition. Equations always have
An answer.
equal signs. Equations always have equal signs. That's a key to an equation. And this equation is specific in that it shows, I have to put that again, 2 ratios are equal. 2 ratios are equal. That's the key. And that's what ties it into our last lesson. So 2 ratios that are equal form a proportion. Yes. So that's what we're talking about, a proportion. So I'm going to test you out and see if you guys can follow that definition, which is hopefully not too complicated. All right. We're going to look at a lot of proportions today, a lot of ratios, but I'm going to give you the most basic proportion I can come up with. Okay, ready? A over B. Is that a proportion?
No.
No, because it's only one ratio, right? What's a ratio? We got to know what a ratio is or we can't move on. What's a ratio?
It's a comparison of two.
Yep. Do you guys see the 2 numbers that I'm comparing? That's a ratio. Okay, good. All right. Is this now, so what I've added here, is this a proportion?
Any equal sign.
No, it's not a proportion. It's not a proportion. You know why? Because it doesn't have the equal sign. That is 2 ratios equaling one another. That's a proportion. Okay, that is a proportion now. Now, what you're going to be doing half the homework is you're going to be determining, is this proportion that I write up there, is it a true proportion or is it a false proportion? And here's what I mean. If I say that I need to add only 1 cup of sugar for 4 dozen cookies, is that true? according to that 1 dozen recipe? No. So even though I'd say, yes, 1 cup of sugar for 4 dozen cookies, that doesn't mean I'm right. That would be a false proportion.
So it's going to be word problems?
No, it's going to be numerical problems, but it's going to be, you're going to have to determine whether it's true or false. Now, before I get to that, let me show you something here. Guys, have you seen proportions before in math? Yes. Every one of you who have been here last year, so if you weren't here last year, maybe not, but even then, you probably looked at that. Here's a cool fact that's really nice for proportions. I can tell that this is a true proportion by doing this, by using this property called the cross products property. A times D should equal B times C. A times D should equal B times C. And you're like, what are you talking about here? Ready? A times D should equal B times C. Does anyone remember that?
This one is always confusing.
Do you guys? Okay, yeah, sorry. But have you guys seen that where you do something with the A and D and do something with the B and C? Do you guys remember what you called it last year? Okay, it's called cross products or cross multiply. Yeah, butterfly. And then the boys are like, yeah, butterfly. I'm not. I call it the cross slash method. Okay, cross slash. Girls keep calling it butterfly if you want. Cross slash is what I'm going to call it. And the other classes, how they responded. When I said cross slash, a bunch of the boys are like, yeah, cross slash, we're cool with that. I'm like, you respond the same exact way that my 2 sons would respond if I said cross slash. And that gives me hope. You know why? Because my 5 and my 2-year-old are going to act the same way in 7 years.
Oh, no.
That's awesome.
I thought it meant good luck, Charlie.
No, that's not a beat. Okay, let's look at a problem here. Who can read for me on top of page 190, the little paragraph in One High School? Okay, did you read yesterday, Katie?
Yes.
Okay, thank you for doing that. Okay, Caroline, read for me page 190. We're gonna get an actual scenario where we can use a proportion. Go ahead.
In one high school, 56 of 64 graduates go on to college. Another high school reports that 7 out of 8 of its graduates attend college. Do these schools send their graduates to college at the same or different rates?
Okay, so that's the question. Do they send them at the same or different rates? Now, please stay with me right now as I work this problem out, and then I will get your feedback on some things because I know some of you are thinking certain thoughts. Okay, one high school sends them at 7/8 at a rate of 7/8. So 7 out of 8 graduates will go to college. 7 out of 8 graduates will go to college. So that's pretty good. 7 kids out of 8 that graduate will go to college, which is awesome. And then another one, the other school is 56 out of 64. Okay. Shh, did I call on you? Okay, so 56 out of 64 for the other school. And you're like, I don't know. And some of you might be thinking, oh, it's easy to tell. Okay, watch what I'm going to do, and then I'll get your feedback about what you thought to do on these. Okay, so listen. I want to know, are these equal to one another, or are they not equal to one another? That's all I'm trying to figure out in this problem. So you're going to do this on your homework. They're not going to be this easy. We start off with easy ones so we can apply the concept. But here's what I do. There are other ways to do it. In fact, I can think of 4 ways to work this problem out. We're going to work it out one way to get used to that way, and then you tell me the other ways in just a bit. Okay, here's what I'm going to do. I'm going to multiply 7 times 64, and then multiply 8 times 56, and see what comparison symbol goes between those two. So go ahead and do that real quick. Multiply those two out. You may begin now. Do you have a question? Yes.
So I don't understand when people say 7 out of 8 in commercials too.
Yeah,
How do
yeah.
they get that number?
So they have to. What they do is basically this. If I ask you all, how many of you enjoy your lunchtime at the time it is right now? So currently, and 10 of you raise your hand, right? 10 of you would raise your hand, and there's 20 of you. I could say half our students like lunch the time it is. So 50% of the students like how it is, or 1 out of 2 students like it. They took a ratio 10 to 20 and they just reduced it. But what they do actually is they take 1,000 people They see that 700 of them like it, 300 don't. So they'll put 700 over 1,000, which reduces to 7 out of 10. So they just take big numbers and reduce them. They do what we like,
Makes it still
simplify. They make it simplify. And they can round a bit because 733 over 267, it's basically 70%. Okay, yep.
Wouldn't it be simpler to simplify the...
Wait on your question, sir. Thank you. Because I'm going to tell you this. I'll get that answer, and then I'll give you another problem later on. I'll say what to do. Yeah. But yes, you could do that, and I'll have you share that in just a moment. All right, what's 7 times 64? Somebody? Yep. 448. Okay, 448. What's 8 times 56? 448. Okay, now, are these two cross products equal to one another?
Yes.
These are equal. Therefore, this is a true proportion. And that's what you're going to be doing on homework. Just tell me if they're true, or if they were not the same, you would have put a not equal to sign. That's all you're doing on that part. Now, what's another way you kind of work this problem out? Because I'm not going to say that that's the only way you can do it. There are actually 3 other ways. Can you figure them out? Aiden.
Yes.
Hi. You've been waiting to say this.
Well, you can simplify those ones already.
Wait, which ones?
Those
56 over 64 to its simpler form or simplest form, and then
Good.
you compare them directly.
Yeah, so what goes into 56 and 64 evenly? 8. It goes into it 7 and 8 times. So, oh wait, they're exactly the same. So yes, they're equal. What's another way you could have done? Remember, there are other ways. Raise your hand. Yes, Ruth?
Well, I just simplified 56 and 64 and then still multiplied 7 times 8 and 8 times 8
Oh, okay.
and got 56 is less than 64.
Okay, if you did 7 times 8, that's 56, and 8 times 7 is also 56. So you still get the same answer. Okay?
Oh, yeah.
Go ahead, Tyler.
You could do the thing where you do the cross thing and make them smaller, like that.
Yeah, you can simplify quicker.
Yes, you can simplify numbers, and I think that's kind of what, if you simplify them all the way, you get 7/8. So you just do these two, 56. Those two, 56. Same thing. Could you do this? 7 times what equals 56?
8.
Does 8 times 8 equal 64?
Yeah.
So the same number you would multiply the numerator and denominator, you'd get that equal to. So a lot of way. Another way, guys, here's the 4th way. It's not as nice, but it works. 7 divided by 8 and 56 divided by 64, same quotient, same exact thing. But what should we do on a problem like this? Okay, here's the next one. Ready? I don't know if I should do this one yet. Yes, I will. Okay. 3/4 and 105 over 140. Okay, I want you to tell me if there's an equal to sign or not equal to sign right there on that proportion. So it's either a true proportion or a false one, but you have to determine the best way to do it, guys. I'm telling you, this is the best way, but you can also do other ways. 3 times 140 and 4 times 105. So figure out what those are. If they're the same, great. Equal to sign. If they're not the same, not equal. No, do it cross products. And again, Aiden, I haven't even got to that problem where using other methods may not be so helpful.
Can you check it with the other method?
Yeah, of course. Yep, that's nice. Check it with another method. Okay, ready? Stella up front. What is 3 times 140? 420. 420. Stella back there. What is 4 times 105? 420. Look at that. Do these two equal?
Yes.
Therefore, these two are proportional. There's an equal to sign right there. That's all you're doing. Pretty simple, right?
I swear, if there's like a twist or something where it makes it harder.
But
It's pretty simple.
Oh, you mean this one?
No, please!
good
Wow.
job.
All right, guys. This method, the cross products method, always works. It'll always give me a true or false proportion, and then I know for sure. Because sometimes up here, I can't really see it. Other times I can. But let's check it out. Maybe on this one. 1/2 over 5 equals, time out. I don't want to do this one yet. Let's do another one. Oh, here we go. 2 2/7 over 7 is something to 7 over 5. 7 over 5. Don't give out any answers. I'll start filling out your questions I think that you may have. All right. Yes, it's a mixed number over a whole number, and you do have those kind of fractions. It's complex because I have 2 fraction bars, but you have them all the time, unfortunately, and fortunately. But I want to know, wait, are these 2 proportional? I have no idea, so we can figure it out. So I'm going to do this. 2 2/7 times 5, and then I'm going to do 7 times 7. And be thankful. 7 times 7 is awesome, 49. So I already know that one. Now, just a reminder about this problem right here. When you're multiplying mixed numbers or whole numbers together, what can you do with this mixed number?
You can put it into a fraction.
Yeah, so I get 16, make it an improper 16/7, and then make that other number also improper. And you can multiply across. If you can cancel things, you could do that first, but 16 times 5 divided by 7.
8 over 5.
Yes, Camille, what is it? That.
16 over 35.
Oh, I see. Okay.
Yeah, wait.
Yeah. See how there's a multiplication symbol here? Did you do a cross product? Did you do 16? Okay, just multiply it. You're just multiplying it.
Okay, Camille. Wait, sorry.
So what's 16 times 5?
8 fifths. 80.
80 over
7.
80 over 7, which reduces to 11 3/7. If you change it to a mixed number, back into a mixed number.
I did not get that at all.
That's okay. Did you get 80 over 7?
No, I
I
got
have a
8
question that everybody will hate me for.
Because I did 16 over 5 times 5 over 1. I just went across.
Oh, yeah. Well, you just multiply across, you get 80 and 7. So you get 87ths, and that's 11 3/7. Okay, are these 2 right here equal to each other? No, they are not equal to each other. Therefore, this is not a proportion.
Wait, how'd you get? What about?
I did 80 divided by 7,
Oh,
and that's 11 times the remainder of 3.
I wrote it down wrong as 16 over 5.
Ah, God, that would make sense now. Because now what you said, okay, it's all coming together. Now, what's another way that would have told you that these were not proportional? I want to see if you're thinking about numbers. Cool? Look at the original problem. How could I have already told that these were not proportional? They were not. Now, some of you are going to give me this answer that's commonly given, and then someone may come up with the correct answer. What do you think? Any hints up there? Okay, that's all right. We'll go with Audrey. Any hints that this was not proportional? Like you just like that? We didn't have to do all that. And it's not always what you think. Okay, let me give you the answer that is not the case. Not true. Just because you have a mixed number doesn't make it a wrong. Doesn't make it a not proportion problem. You're going to get some that look like this, and it's going to be a proportion. That's not the reason why. But there is another reason. Mary Addison. Oh, okay, 3/7 means like 7, 7, 7. You can have that, and it can still be true. But there's something that's telling me, wait, look at it. Jimbo?
So on the previous problem, you were talking about a way that you could like multiply by the same number.
Okay, yeah.
But you can't multiply by the same number because 7 is more than 5, and 2 2/7 is less.
Okay, that's it. Here it is. Look, ready, guys? You have a small number over a big number, right? This is like 3 over 7, maybe. Or 2 over 7. And that's 7 over 5. One value is less than 1. One value is greater than 1. Can they be the same? No. So that's one way you can check it. You should know, not proportional.
Wait, can you explain that one more time?
Yeah. Let's round this to 2. would 2/7 be close to 7/5?
No.
No, 2/7 is below 1, 7/5 is above 1. So they can't be the same thing. That's just one way. But again, cross products will tell you for sure.
They had different denominators.
Oh no, again, they can, I'm going to throw some random problems and they're going to be, or not.
I thought it was like the
Problems.
denominators, like all of them could go into each other. Because like 8 times 8 is 64.
Oh, okay, yeah, sometimes they all go into each other. But again, that problem could have been true. Even with all the weird stuff going on. It can be. Let me give you another problem here. All right, guys, any questions on knowing whether to say equal to or not equal to? Like, do you get cross products? You get how to figure that out? Okay. Here's the second type of problem. Now, this is what I wanted before. 1/2 over 5. Don't be scared of that because you just saw a scarier looking one on the last problem. Okay, is that a proportion?
No.
It has an equal sign.
Yet. There's not enough. Because there's not 2.
I need 2 ratios here. Okay, here's the second ratio.
What's A?
Great question. Okay, is this a true proportion?
No.
Is it a false proportion?
No. It can be.
All right, I heard no, it's not true. Yes, it is true. It can be true. It can be false. Okay, guys, listen. You guys, I think you're getting it. This is neither true nor false because I don't know what A is. I got to figure out what A is. I want to prove that this is a true proportion by finding A. Now watch this. This is the cool part. How in the world would you figure that out? Because this is weird.
Well, since it is a proportion.
Oh,
Is it the thing?
What can you use?
you have to do the thingy that we did.
What's the thingy called? Cross slashing. Yes.
I thought you had to do like the
I mean, you could, you'll get it, but watch this. All right, ready? I'm going to do 1/2 times 4.
2.
Yeah, which is going to give me 2. And 5 times A.
5A.
5A, good. So what's 1/2 times 4?
2.
I'm amazed.
And then again equals 5A. But
Divide by 5, divide by
but it's like, it gave me an equation, and I have a variable, and it's like I had to solve for that equation, and we haven't done that in like,
Wait, why
A
did
week.
you put an equal sign? Why did you put an equal
because remember, these two cross products have to equal each other. No, they are equal, but when A equals something, we got to find out what A. This time, I got to know what A is. Okay, yes.
So do you have to do like where you have to -2 and then do it on both?
Close. Not -2. Look at A. What's happening to A?
Divide 5.
Good job, Caroline.
Okay, I am saying that A equals 2/5. That's what I'm saying. A equals 2/5. Now listen to me. Some of you could have maybe come up with that. Some of you totally did not come up with that on your own. But here's how I know 100% that that's the correct answer. Ready? What is 1/2 times 4?
10 over 5.
Sorry, 1/2 times 4.
Sorry.
2. What's 5 times 2/5? I'm going to work that out right here. 5 over 1 times 2 over 5. These cancel out. Oh, that has to be A. And that's the only number for A that works.
So it's equal?
Mind blown.
Okay, now listen to me. Here's what I'm going to make you kind of think of. Okay, on the other problems. On the other problems, do you guys remember there was a big circle here?
Yeah.
And we had to put in an equal to sign or not equal to sign, right? So I had to see if it's Reese. Do you know what I'm saying? Okay, so I'm going to put an equal to sign or not equal to sign. What sign did they already put?
Equal.
So I know it's a true proportion. My job on these problems, I want to know what that's worth. That's solving a proportion. Okay, let's do it again.
So it's always like if they have like the equal sign.
Then you already know it's true. I just got to know what that variable is. Let me give...
Equal sign, then you can just put a random number and still be right.
Okay, here's another one that I want you guys to look at. It's a little different, but I hope you guys can handle it. Okay, n:6, and then equals 0.4 colon 12.
Oh, I get it.
Okay. Now, guys, this is weird because we haven't worked out a problem like this yet. But do you guys remember what form this is written in? I think yesterday. What form is this written in?
Weird form.
Ratio.
Ratio form. Just write it in fraction form. So how do I write this as a fraction? N over 6. And then the second one?
0.4 over 12.
All right. That's fraction form, and there's still an equal sign. That is a true proportion. My job, find n. That's what I want to know. Find n. Find that value. Okay. Many ways to find it out. Cross multiply. Cross multiply. What's n times 12?
12n.
What's 6 times 0.4? Good. 2.4. Now, listen to me carefully. The way to do 6 times 0.4, just do 6 times 4. That's 24. And then how many decimal places were in this?
1.
It's just 1, so you put the decimal right there. All right. They're equal. So how do I solve for n?
You do 12 divided by n, and then, or 12,
Divide both sides by?
and divide by 12, and then you get 2.
N equals 0.2. Yeah, there you go, 0.2.
Wait, how did you get 0.
I did 2.4 divided by 12. Hold on. So let me show you here. 2.4 divided by 12. Bring that decimal point. 12 goes into 24 twice. So 0.2. No, on this? No, only move it if it's on the outside. Yeah, you don't want to move it there. Okay, yes, you could have done it that way. Remember,
Simplifying it down to the same level, so it would be
Aiden, that would be very impressive for what grade, do you think?
2.
5th and 6th.
Yeah.
5th and 6th, I'm like, whoa, you thought of that? And then 7th and 8th.
Wouldn't you?
Let's think about it algebraically. No, I want you to be more understanding of the problem. Okay, anyway, let's go through another one. Last one here. Okay. This is a bonus one. I had the other class, there's 19 of them. I wanted 3 of them to get it right. I want 3 of you to get it right. Proportional, kind of, because they have 19, you have 20. Wait, you have 19 now.
3 or more.
Wait, who's missing?
Sammy.
Wait, do you have 20 or 21? Anyway, it's pretty proportional.
You don't know that.
Okay, here we go. I want to know what the variable is. That's a z.
No, today we have 19.
You have 19 today? Okay, so then, oh yes, you do have 19. Okay, good. So it's exactly the same. Proportional.
Today.
Yes, today. So, I want you to find what z is worth. Find what z is worth. 3 of you need to get it right. 4 of them got it right in the other class. So they barely passed that. Let's see if you guys can pass it. Yeah, don't give it to me yet. Okay, looking at this, the hard part about it is that you have 18 plus z. That's the hard part. But you handle it just the way you did the other problems. Cross multiply. Cross multiply. You're like, okay, what do you mean? I'm going to multiply 18 plus z times 8. But you got to do it this way. 8 times 18 plus z.
Yes.
8 times 18 plus z. You got to do this times that right there.
144.
Oh, okay, 100. Well, it's 144 plus 8z. You got to do your distributive property right there. 8 times 18, 8 times z, right there. That's the hard part. 56 times 3 is,
168.
yeah, 160. I think it's, yeah, 168. Yes, good. 168. Okay, this is your equation. Solve for z.
I did 6 times b equals 9.
Subtract 144 from both sides. Because you did 8 times 18. And then you get 8z equals 24. Then divide both sides by 8. Z equals 3. Oh, 3. All right. Ma'am.
So like,
I've been doing it.
Good, because you will do it.
Why cross multiplying is the easiest? Because I got it right and all I did was 56. Like, just.
Oh, 7. Did
I
you?
just did, it's over 56, so I did 3/8 times 56. And then
3/8.
minus 18.
Okay.
So, like, I don't get why I crossed.
Yeah. No, I understand that. Look at number 8 on page 191. So look at it. Do the same thing, and I will stop talking about it, if you could do it that way. Okay. How many of you got z equals 3, though? That's what I want to know. Z equals 3? 1, 2, 3. 3 of you made it. That's good. You made it past this round. How many of you did not distribute? You did 8 times 18, but not times z?
Yeah.
Right, that's the part you came out. That's okay.
I was just confused.
Now, on the homework, I'm not giving you ones with this, but we will get to that later. We will have to be able to do that before the quiz. Yes, it will come. But I just wanted to give you a little taste of that. Yeah, and Camille, honestly, some problems you could do it different ways, but when they start throwing you decimals and fractions, yeah, that's what I look like. Did you get that, Swivel? Okay, good. Swivel's back, yes, and he recorded. Yes, he is on. He is, yes, he's on. Perfect timing. All right. Homework. 2 types of problems you're doing. You are either saying it's true or false, or you're finding what the variable's worth.
I was guessing the whole.
Awesome.
I wonder.
Good luck. That's page 1, 213, 214.
I guess the freaking page numbers.
All right, goodbye, Civil.